My topic is on biological management of root rot disease in Gloriosa superba. This Gloriosa superba is an important medicinal plant belonging to family Colchicaceae. It is commonly called glory lily. Here the propagating material is tuber, and the seeds and tubers, it contains lot of alkaloids, namely colchicine and colchicoside, and mainly it is used for the treatment of arthritis, leprosy and cancer. In Tamil Nadu, this Gloriosa superba is cultivated around 5,000 acres, mainly in Tirupur, Coimbatore and Karur district, and some packets in Jayamkondam and Thiruvannamalai districts. Here, the soil-borne diseases play a major role in the Gloriosa cultivation. Here, the root rot disease caused by the fungus Macrophomina fasciolina. It is a devastating disease in Gloriosa superba. Here you can see the leaves become yellow and the plant becomes weakened and easily come out by pulling. You can see the dark black lesions on the stem portions, and this is the severe infection of Macrophomina on the Gloriosa plants. Here you can see the minute black sclerotia also on the stem portion. This is the advanced stage of root rot disease. You can see the complete drying of entire field, and the entire field looks like a burnt up appearance. And this is all the sclerotial bodies observed on the stem of Gloriosa plant, and sometimes the mycelial growth will be covered in the Gloriosa stem, and the tubers will be completely rotten and covered with white mycelial growth. If the tubers are affected by this tuber rot, the tuber will fail to sprout and it causes complete failure of the crop. Then these are all the pycnidal bodies observed on the stem. It's a flash-shaped structure, and these are all the pycnidiospores. Here the yield loss due to this root rot disease is about more than 40%, and being the medicinal plant, the use of chemicals should be totally avoided, and so the biological control is the successful alternative for the management of Gloriosa, and moreover the use of fungicides would lead to development of resistant strains in the pathogen. So why we are going for the biological control? It is eco-friendly method, it is also economical, we can easy to apply, and among the various biocontrol agents, I use Pseudomonas fluorescens in the present study. So coming to the mode of action of Pseudomonas fluorescens, it has the plant growth promoting activity by producing various growth regulating hormones, and it also produces various antibiotics that are toxic to pathogen. It produces hydrophores that are toxic to soil-borne pathogens, and it also produces hydrogen cyanide which are lytic to pathogen. And Pseudomonas fluorescens produces many lytic enzymes like beta-1,3-glucanase and chitinase, which will degrade the cell wall components of fungus. And very important mechanism of Pseudomonas fluorescens is the induction of disease resistance. And this is the pathogen Macrophomina fasciolina isolated from the infected roots, and this is the soil-borne fungus. From the culture, we have seen the sclerotial bodies, which are all the black, irregular shape and with mycelial appendages. And the sclerotia survives in soil for more than 20 years, so very difficult to eradicate this pathogen, and farmers are facing lot of problem to eradicate this disease. We have isolated several isolates of Pseudomonas fluorescens from the rhizosphere, and among the 6 isolates, in vitro condition, this PF1 isolate, it inhibits the pathogenic growth very effectively, whereas in control, the maximum mycelial growth was observed. And this is the in vitro inhibition of Macrophomina fasciolina by various isolates, and this PF1 isolate effectively control the pathogen when compared to control. And this is the effect of Pseudomonas isolates under pot culture conditions. Among the various isolates studied, this PF1 isolate is effectively controlled the root rot disease when compared to control. The mode of action of Pseudomonas fluorescens by different isolates was studied, and this IAA production is one of the mechanisms for plant growth promoting activity. Among the different isolates, this PF1 isolate, it produces more IAA, which will contribute to PGPR activity when compared to other isolates. These are the lytic enzyme production by Pseudomonas isolate, and the chitinase activity found to be more in PF1, and this is the glucose activity, it also more in the effective isolate. So these lytic enzymes will degrade the chitin and glucan, which are all the components of fungal cell wall. The salicylic acid production is one of the mechanisms for Pseudomonas fluorescens. So among the different isolates, the salicylic production also maximum in PF1 isolate when compared to control. The salicylic acid, it produces the signal molecules which will induce the resistance in plants. So siderophores, these are all the ion chelating substances produced by Pseudomonas which will chelate the ion present in the soil and make unavailable to pathogen. And the siderophore production is correlated with the antagonistic activity against soil-borne diseases. Among the different isolates, this PF1 isolate, it produces more siderophore production. And this is the, you can see the clear zone around the Pseudomonas colony which indicates the siderophore production by Pseudomonas fluorescens 1 isolate. And these isolates were tested for hydrogen cyanide production. Under qualitative assay, the PF1 and PF2 isolates produced hydrogen cyanide, and the quantitative estimation, this PF1 isolate produced more hydrogen cyanide followed by PF2. This change of the filter paper disc from yellow to brick red color, it indicates the hydrogen cyanide production by Pseudomonas, and in control there is no change in the color of the filter paper disc. So the effective isolate PF1 was used for further study, and this PF1 was mass multiplied using talc as a substrate, and these are all the PF1 colonies isolated in talc formulation. So the effect of PF1 talc-based formulation was tested for the management of root rot disease in the farmers field in hotspot area. The tubers were dipped in Pseudomonas suspension 2 gram per liter, and soil drenching was done at 30 days after planting. The combination treatment of dipping the tubers and drenching with Pseudomonas was also done. For comparison, the tubers were dipped in the fungicide carbendazim, drenching was done with carbendazim and combination treatment. We found that the root rot disease was effectively managed in the combination treatment of dipping the tubers followed by drenching on 30th day after planting. It recorded very less root rot disease incidence as compared to control. This plant growth parameters, namely plant height and number of flowers, were also recorded and found that the plant growth parameters were maximum in the combination treatment of Pseudomonas fluorescens when compared to control. So the yield attributes, namely number of pods, number of seeds per pod, were also recorded, and the yield parameters are also found to be enhanced by using Pseudomonas fluorescens when compared to control. So the seed yield was recorded, and seed is the economic part used for isolating the alkaloids, and seed yield was enhanced by using Pseudomonas fluorescens treatment when compared to control. There was about 34% yield increase in Pseudomonas treatment. This shows that Pseudomonas fluorescens, in addition to disease reduction, it also enhanced the seed yield and plant growth promoting activities. This is our field experiment conducted in the farmers field at Darabra, and in hotspot area, this is the main hotspot area for the occurrence of soil-borne diseases. In this photograph, you can see the plant growth promoting activity. This is the combination treatment of Pseudomonas, dipping and drenching. You can see the yield increased. These are all the pods, and this flower Gloriosa is the state flower of Tamil Nadu. So the mechanism, important mechanism is induced systemic resistance. So we also studied the ISR mechanism. This phenylalanine ammonialase is the key enzyme in the phenyl propanide metabolism, which leads to various phenolics and phytolexin accumulations which are associated with disease resistant. So this is the control, and this is only pathogen inoculated, and this is only Pseudomonas, and last one is the Pseudomonas plus pathogen. We observed that the PAL activity was enhanced several fold when the Pseudomonas fluorescens treated plants were challenge inoculated with pathogen when compared to control. Similarly, the phenolic contents are fungitoxic substances, and we found that this maximum phenolic content was found in the Pseudomonas plus pathogen when compared to control. This chitinase activity is also estimated and found to be maximum in Pseudomonas plus pathogen. And gluconase activity was found, this even compared to Pseudomonas, when it was challenge inoculated with pathogen, the ISR activity was increased several fold. So we found that Pseudomonas fluorescens can be effectively utilized for the management of root rot disease, and also it increased the yield. And systemic protection was observed by using Pseudomonas fluorescens, and various defense compounds, namely chitinase, gluconase, PAL and phenolic compounds were found to be induced by using Pseudomonas fluorescens. So both direct inhibition of the pathogen and induced resistance are associated with Pseudomonas in managing the soil-borne diseases of Gloriosa superba. So using Pseudomonas fluorescens will definitely be a successful eco-friendly method for managing this disease. Thank you.